Okay, we're going to cover 3-4, 3-5, and 3-6. 3-4 kind of picks up right where we left off, as well as overlaps a little bit with stuff we talked about last time. But 3-4 is going to focus almost completely on slope. Now, slope we did talk about to an extent. Oh, that keeps this poor document cam. I apologize. Slope is a measure of steepness. It is always the rise over the run. So given a line, it's how much you go up compared to how much you go over. So you count your rise, you count your run, and then that establishes your slope. Remember, if it goes up and to the right, that is a positive slope. If you go down and to the right, that's negative. Remember, horizontal is a slope of 0, and vertical, that slope is undefined. These two are very different. Having a slope of 0 and then a slope that is undefined are very, very different things. Anyway, 3-4 is going to ask you to find slope given a number of different representations. The easiest is if they give you a line, if they graph it, they should mark out a couple of coordinates. And again, you just count. You count your rise compared to your run. If you rise down, that's negative. If you run, that would be positive. So the first thing they could do is they could give you a line, okay, in which case you basically just count. And remember, it's the rise, the up and down over the run. Now, because we write slope as a fraction, if you can reduce, you need to reduce. For example, if this is a rise of -2 and a run of 4, we would need to reduce that to a -1/2. So slope reduces just like a fraction. Now, that being said, do not make it a mixed number for whatever reason. So let's say we have a slope that kind of does this number here. Say we go up 3 and over 2. We would leave that improper. So 3 over 2 is good. Do not change that to a slope of 1 1/2. While it's not technically wrong, it's also not technically right. Slope should be rise over run. When you write it as a mixed number, that kind of messes with the representation of it all. So don't make it a mixed number. Also, you typically do not make slope a decimal. So while yes, 3 over 2 is equal to 1.5, when we're talking slope, we don't want that. Leave it improper if it is improper. Proper fractions are fine. Improper fractions are fine. Don't make it a mixed number or a decimal if you can kind of keep from it. So like I said, one thing they may do is they may give you the line, in which case you can just count up and down compared to left and right. Now, another way they may represent slope for you to solve is given a couple of coordinates. For example, they may give you 2 points and be like, hey, what is the slope between those? Obviously, you could graph those and count just like you would on a line. But if they give you some crazy points like 134, you know what I mean? Or -2, like if they give you gigantic points, you don't want to have to graph that. So there's a formula. You can take y minus y. So your y coordinates, remember your x coordinates are first, y's are second. So if you take y minus y, over x minus x, that will give you the slope. I apologize. I don't know why this thing won't stay focused. Keeps going blurry. But anyway, so if you take the y's and subtract them, so 4 minus -2, when you subtract the negative, that's adding. So 4 minus a -2 is like 4 plus 2, and that's 6. X minus x, so 3 minus 5 is -2. Positive 6 divided by -2 is a positive, or sorry, a negative 3 over 1, or just -3. So if they give you 2 coordinates, you can subtract your y's on top, subtract your x's on bottom, and that will give you your slope. And again, if you can reduce, you need to reduce. And again, I'm perfectly fine with a slope of -3 over 1. My math lab may want you to just change that to -3. So just pay attention to what my math lab is specifically asking for. Okay, so doesn't matter what kind of coordinates they give you. Again, y minus y over x minus x. If you're subtracting a negative, again, that's the same as adding. So -3 plus 1 would be -2. 5 plus 6 would be 11. So that would be my slope. So again, they can give you the lines and you count. They could give you a couple of coordinates. And again, subtract the y's on top, subtract the x's on bottom. That gives your slope. The other thing they could give you is an equation. And remember, if you have y by itself, then we are set up in what we call slope intercept form. This y equals mx plus b is referred to as your slope intercept form. And this is really convenient because if y is by itself, whatever number is here times your x, that is your slope. So if they give us the equation in the correct form, just the number times x is your slope. This equation would have a slope of 4. Now, another notation for slope, instead of writing the word, because of that y equals mx plus b, they may just refer to the slope as a letter m. That means slope just as well, based off of the formula, mx plus b. Now, if y is not by itself, we can use algebra to get it there. For example, if they said, here's your equation, and they ask, what's the slope? This line, you can get y by itself. So typical algebra stuff, if when you get rid of the 3x, we're going to subtract it. We want to get rid of multiplying by -2, we're going to divide. Negative divided by a negative is a positive. Positive 6 divided by -2 is -3. And again, if they specifically want the slope, all we're concerned with is that number. So we would say that our slope is 3/2. If they ask for the y-intercept, that's that number. And remember, if they ask for the intercept, you need to give your intercept as a coordinate. Okay, we don't just say that there's a y-intercept of -3. We're talking about a specific coordinate. So anytime you give a y-intercept or an x-intercept, make sure you give it as a coordinate. That's important. So most of the questions, they're just focused on slope. Every once in a while, they throw in something from a previous section where they're asking about, say, the y-intercept or the x-intercept. So you should be able to do that too. Another thing they can do with slope is they could ask you to compare slopes. When you compare slopes, it'll be one of 3 situations, okay? If your lines have the exact same slope, then they're what we call parallel lines. They run right next to each other. So parallel lines will have the exact same slope. For example, if I have these 2 lines, so y equals 1/2 x plus 1 or y equals 1/2 x minus 3, again, if we just compare the slopes, if those are the same, exactly the same numbers, same positive, negative, same everything, if those are exactly the same, then we say that those 2 lines are parallel. They're going to rise and run at the exact same rate, and they will never, ever, ever cross. Another situation is what we call a perpendicular line. These are just some geometry symbols for those, but perpendicular lines will have opposite and reciprocal slopes. Both. Opposite means one will be positive and one will be negative. Reciprocal means they will be flipped over. Okay, and those are called perpendicular lines. perpendicular lines cross, and they specifically cross at 90-degree angles. It's a very specific type of line. So again, it'll look something like y equals 2/3 x plus something, and then y equals -3/2 x and something. So again, if you're looking at your slopes and one is positive and one is negative, and they are the flip of each other, then those are perpendicular. Again, both of those things have to happen. It has to be one positive and one negative, and they have to be flipped. If both of those things are the way it is, then your lines are perpendicular. If they're exactly the same, they're parallel. Any other situation, then they're just lines. They are not parallel. They're not perpendicular. They're just neither. Okay, they're just regular intersecting lines. Where they try to trick you is they like to give you something like this and make it really close. So those are almost the same, but not quite. One's positive and one's negative. Now here one's positive and one's negative, but they're not flipped. See, they're the same. So this would be an example of neither parallel nor perpendicular. So again, parallels are going to run right side by side. Perpendiculars will cross at a 90-degree angle. These are just two lines that are going to cross somewhere, somehow, some way. Okay, so they're going to try and trick you by making them really close to looking like one or the other, but they're not. So again, parallel, exactly the same. Perpendicular, opposites, one positive, one negative, and flipped. Now, also going with the perpendicular, remember, okay, the flip of a whole number is with a 1, because remember, a whole number, if you write 3 as a fraction, 3 is technically 3/1. So then if we flip 3, that's where we get that 1/3. So that says y equals -1/3. So this is another example of perpendicular slopes. So that's basically 3-4. We're able to cover that pretty quickly because I've already talked about slope. That's how we were graphing lines in 3-3 and actually 3-1. Okay, we've already talked about that. They're just going to be asking you to find slope. Now, I did talk a little bit about horizontal and perpendicular, so be aware of that too. If you have a horizontal line, remember that that has a slope of 0. Okay, what that looks like with points is you'll have the same y coordinate. Okay, your x's can be different, but if you have the same y coordinate, okay, that's going to give you a slope of 0, which makes sense because if you subtract your 6 minus 6 over 2 minus 3, you're going to get 0 over some number, and 0 divided by anything is 0. If they give you an equation, it will be a y equals equation. This is also horizontal line, slope of 0. If I gave you the line y equals 6, I think we talked about this, that would give you a horizontal line at 1, 2, 3, 4, 5, 6, wherever your y says. And the flip of that, so if you have a vertical line that has a slope that is undefined, so again, by coordinates, you're going to have the same x. Your y's, whatever, but your x's are going to be the same. And what this looks like, so if we try to do this, so we do 3 minus 1 over 4 minus 4. That gives us a 0 on the bottom. You cannot divide by 0. Okay, in math, division by 0 is undefined. So there is no slope for a vertical line. It is undefined. And the equation for that, again, is an x equals equation. So again, if the x's are the same on the coordinates, okay, that's a vertical undefined line or undefined slope, vertical line, x equals equation. And just so you know, these two things would be perpendicular to each other. So if it says, hey, if you've got a y equals and an x equals, what kind of lines are those? All right, those are perpendicular. You've got a slope of 0 and a slope that's undefined. Those would be perpendicular to each other. But anyway, That's another thing they may ask as far as slope goes. All right. Switching gears. 3.5 basically does everything in reverse. So if you really look at the first couple of sections we talked about, it's like, okay, here's an equation. What is the slope? Or what is your y-intercept? Or what is your x-intercept? Or hey, graph this. Okay. They can give you an equation and they can ask a bunch of different questions for this, like what's the slope, y-intercept, x-intercept, graph this. Okay. 3.5 is going to go backwards. They're going to give some information and they're going to say, hey, write the equation. Okay. To do so, there's a formula for that. It's called the point slope formula. This is going to be important to know. We're always looking for 3 pieces of information, which we can plug in. And then when it's all said and done, we're going to end up with an equation. But this is called the point slope formula. And this is what we're going to use. Okay, so I'm going to go over all of the different types of things they can give you, and then we'll work on how to write the equation from that information. So one thing they can give you is slope and a coordinate. For example, write the equation for the line that goes through the 0.45 with a slope of 1/2. So they want us to write the equation for the following information. They gave us slope and a coordinate. So again, we're going to take that point slope formula. So y minus y1 equals m times x minus x1. And we're going to plug our stuff in. So we're going to do y minus our y. So in this case, okay, there's x, there's y, there's m. So our y is 5. M is 1/2. And x is 4. So again, I'm sorry, it keeps kicking out blurry and focused, but this is what we're plugging in. So our y coordinate goes in for that y1. Our x coordinate goes in for that x1. And our slope goes in for m. So again, we're going to use that point slope formula. We plug our 3 pieces of information in, and then we're going to solve for y. So if we distribute here, so half of x, half of 4 is 2. Add 5 to both sides. Y equals 1/2 x plus 3. So there's my equation that follows the given information. It's going to go with the right slope, and that coordinate would fall in on this line if you were to graph it. Now, most of the time, okay, and in fact, I don't care. I will allow you to give your equation in slope intercept form. This is perfectly good and totally makes sense. There are a couple of problems in your homework on my math lab that are specifically going to ask for standard form. Standard form is just another way to write an equation. It wants x and y on the same side equaling some number. So to get into standard form, you got to get your x and your y on the same side, and they don't want any fractions. So if we want to convert this to standard form, we got to move our x over. So we add the opposite. So negative 1/2 x plus y would equal 3. And we got to get rid of our fraction. So we multiply by that bottom number. So to get rid of our 2, we're going to multiply everything by 2. So we get negative 1x plus 2y equals 6. So this is the same equation, just in a different form. This is, again, very specifically what we call standard form. And you'll see that on MyMathLab. In fact, I think they let you type it in slope-intercept form-wise, and then it'll give you another button. It's like, hey, what would this look like in standard form? And that's where you got to get your x and your y on the same side and no fractions. So on your test, I don't make you do it in standard form. I'm perfectly fine with slope-intercept form, but I do know that there are a couple of problems on MyMathLab that specifically ask for standard form. So you need to be able to convert it and just add the opposite to get your x over and then multiply to get rid of your fractions. Okay, I'm going to do one more where they give you slope and a coordinate. Okay, so again, write the equation with a given slope of 3/7 that goes through the point 5, -2. This is going to give us some ugly fraction, but I'll show you that it's still very, very doable. Okay, again, same formula. So y minus y1 equals m times x minus x1. And I'm just going to plug my stuff in. So my y is -2. My x is 5. My slope is 3/7. Okay, again, if I want to get y by itself, subtracting a negative is adding. Distribute 3/7 times -5 would be a -15/7. If we subtract 2 from both sides, y equals 3/7 x. You got a calculator, you can just do that -15/7 minus 2, and it'll do it. You should get -29/7. Okay, and again, slope-intercept form, this is perfectly fine. If they want standard form, you move the x over. To get rid of the fraction, we multiply by the denominator, so we multiply by everything by 7. We get a -3x plus 7y equals -29. So again, that would be standard. This is slope-intercept form. And if they don't specify, slope-intercept form is fine. If they specifically want it, then that's how you would do standard form. Now, those are the easiest problems. Like if they give you the slope and a coordinate, they've given you all the information you need right off the bat. Really straightforward. Okay. Again, they love to be tricky, and they're not going to do that. Sometimes they give you instead 2 coordinates. Write the equation that would go through the following, and just pick 2 coordinates. Say we want to go through the coordinates 3, 4, and 1, 2. Okay, we're going to use that same point slope formula. Okay, the difference is they gave us 2 coordinates and no slope. So step 1, we got to find the slope. Remember, to find slope, it's y minus y over x minus x. So again, if they give you 2 coordinates, step 1, you got to find the slope. Subtract your y's on top. 4 minus 2 is 2. Subtract your x's on the bottom. 3 minus 1 is also 2. 2 over 2 is 1. So there's my slope. Come on, focus. There we go. Okay, so there's my slope. Now, when it comes to plugging your information into this equation, we definitely need our slope, but we need one of these coordinates. Don't steal from both, just pick one. And it doesn't matter which one. If we did everything right, okay, this equation should go through both of these coordinates, so it doesn't matter. I'm going to just pick the 3 and the 4. It would be the same if you pick the 1 and the 2. But anyway, so my x is 3. My y is 4. And my slope was 1. Other than that, everything's the same. Distribute. Add 4 to both sides. And there you go. So if they give you 2 coordinates, find the slope first, then pick one of your coordinates and use your point slope formula. Focus. Okay. Now, the only time that would change is if the 2 coordinates they give you have the same x value. Okay, remember, if we go to find our slope and we do 2 minus 4 over 3 minus 3, okay, we get 0 on the bottom. Remember, that's bad. That means it's undefined. Now, also remember, this is just the slope, and an undefined slope means you have a vertical line. In fact, specifically, we've got a line that's going to cut through the coordinates 3, 2, and 3, 4. We've got a vertical line over here. There is still an equation for that. Remember, for a vertical line, that is an x equals equation. And then because your x's are the same, guess what your x is going to equal? A vertical line is the only equation that doesn't follow that slope-intercept form, okay? There is no slope-intercept form for x equals because there's no slope. If there is no slope, then there is no slope-intercept form. The equation is just an x equals. So again, if you have an undefined slope, a vertical line, x's that are the same, okay, you're going to end up with an x equals equation. Every other equation will fall into this slope-intercept form, or you're going to get y equals mx plus b. Even if your slope is 0, okay, it's just y equals 0x plus whatever, and 0x's would be gone. Okay, so the only time you don't have a slope-intercept form is in a vertical x equals situation. Now, the last way they can ask you to find the equation, okay, write the equation of, they may give you some coordinate, and they will want it to be parallel or perpendicular to some other line, okay? There's nothing really over here that matters except for the slope. The slope is the only piece of important information that we're stealing from this, okay? We want our equation to go through this coordinate. So this is my x and my y. So then remember, I need a slope. That comes from this information. And again, if I want a parallel slope, parallel lines have the exact same slope. So I would grab that slope. This 3 doesn't mean anything, okay? So I just need the slope from that line. So again, I would do y minus y equals m times x minus x. Distribute. Subtract 2 from both sides. And there's my equation. Same thing if they did a perpendicular. It's like, I want a line that goes through this point that is perpendicular to this equation. Okay. Again, this is my coordinate that I'm going to use. This is the X, this is the Y that I need to use in my equation. The slope comes from all of this stuff. So I need the slope of this line. So if I get my Y by itself, so I'm going to subtract 2X from both sides. So 3Y equals negative 2X plus 4. Divide, Y equals negative 2/3 X plus 4/3. Again, the only important piece of information from here is the slope. In this case, that negative 2/3. And remember, perpendicular means I want to take the opposite and I want to take the reciprocal slope. So if this line has a slope of negative 2/3, I'm going to use positive 3/2. Because if this is negative 2/3, my perpendicular line has to be opposite. So if this is negative, this one's got to be positive. If this is 2/3, then I got to use 3/2. So again, that point slope formula is Y minus Y equals M times X minus X. So again, this is the X and Y we use. I just needed the slope from that. Distribute, Y minus 0 is just Y. And there's my equation. So those are primarily the situations they're going to give you. They can give you coordinate and slope, which case you just plug those things into your slope intercept form. They can give you two coordinates where you got to find your slope first, then pick one of your points, plug it into your point slope formula. Or they will give you a coordinate and parallel or perpendicular to some other line. Okay, so then the only information that's here we got to use is our slope, and then we use the X and the Y from those coordinates. Then, like I said, just pay attention to the fact that if they don't specify, slope intercept form is fine. If they specify and they want standard form, they want X and Y on the same side and no fractions. So again, with this one, you got to move your X over. So that would be negative 3/2 X, Y equals that negative 9/2. If we multiply everything by 2, we get negative 3X plus 2Y equals negative 9. And that would be my standard form. Okay. The last section, and this one is really kind of a standalone. This one doesn't really match up with anything we've done. And I'm going to tell you where my math lab is going to focus. And I'm going to tell you where I'm going to focus on your test, but they're going to have you do a little bit of some non-linear graphing. Now, non-linear graphing can extend to anything that is not a straight line. My math lab is going to focus on 3 different kinds of nonlinear equations. It will give you an absolute value equation, or an x squared equation, or a equation. Once you understand the basics of how those graph, I'm going to show you how we can graph these just based off of parameter shifts. Okay, this is going to be fairly straightforward, and all of these graph with the same shifts. They just have a different basic shape. So first off, an absolute value function makes a V. Okay, you've got a point here. It's called the vertex. And then it'll extend up in both directions. And this is basically the shape that you're going to use, and it'll shift up and down and left and right, and it may flip over, but this is the basic shape. I don't think they do anything to change the slope of the lines or anything like that. So with an absolute value function, okay, here's what they're going to do. If they add or subtract a number inside of your absolute value, that is going to shift the whole thing left or right. And it actually shifts it backwards to what you would consider. For example, the negative numbers will shift everything to the right that many. A positive number will shift everything to the left that many. Okay. This number, the K, out here outside of the absolute value, shifts the whole thing up or down. This one moves like you would expect. Positives will shift the whole thing up, and negatives will shift the whole thing down. So, for example, if they wanted me to graph, okay, the absolute value of x minus 1 plus 2, okay, the graph normally starts here at 0, 0. These numbers are going to shift left and right and up and down, and that's going to basically move the vertex of my V graph. So again, this -1, okay, a negative here inside is going to shift everything to the right that many units. So we're going to shift to the right 1 unit. This +2 out here, okay, a positive on the outside is going to shift everything up 2 units. So this is now my vertex. Okay, from there we go up 1 and over 1, up 1 and over 1. Okay, up 1 over 1 the other direction. And that's our V. The only other thing they could do, if they put a negative here in front, that is going to flip your vertex, or flip your whole graph over. So if I said the graph y equals negative, absolute value of x, and then say -3. Okay, we don't shift left or right, so we're going to stay here. We are going to shift -3, so this -3 outside is going to shift down 3 units. So no left or right, shifting down 3. But instead of going up here, this negative is going to flip my V over. So instead of going up 1 and over 1, we're going to come down 1 and over 1. So that's how we're going to graph absolute value. So anything inside moves it left or right. Anything outside is going to move it up or down. If there's a negative in front, that flips it over, so it opens down. Otherwise, it will open up. Okay. X squared graphs, okay, these are parabolas. Kind of a U shape. Okay, again, this point is also referred to as a vertex. And then the next point is going to go up 1 and over 1. And then the next one from the vertex, you're going to go up 4 and over 2. So again, to kind of get to those points, over 1 and up 1, or up 1 and over 1, up 4 and over 2, or over 2 and up 4. And that's the basic shape. We call that the parent function. So again, it's kind of the same thing. Okay, anything you add or subtract inside of the squared moves you left and right. And again, it moves kind of backwards to what you would think. Negative will actually shift you to the right. Positive will actually shift you to the left. Outside, that K is going to shift you up and down. Positives go up, negatives go down. And same thing, if they put a negative in front, that is going to flip your U upside down so that it opens downwards instead of upwards. So the shifts are exactly the same. The only difference is what that parent function or what the shape of the graph looks like. So if they want us to graph, let's put a plus there. Do that. So if they want us to graph y equals x plus 2 quantity squared minus 3. Okay, we're going to talk about the shifts. Normally we start here at the origin at 0, 0. This plus 2 is actually going to shift us to the left 2 units. This minus 3 on the outside is going to shift us down 3 units. So now there is my vertex. From there, the parent function graphs the same. So again, we go over 1 and up 1. We go over 2 and up 4. Same on the other side, over 1 and up 1, over 2 and up 4. It should make this kind of U-shaped graph. If they put a negative in front, so y equals negative, quantity x minus 3 squared. Your shifts are all still the same. This minus 3 here will shift us to the right 3 units. There is no plus or minus out here on the outside, so we don't shift up or down. This is my new vertex. And like I said, normally we go over 1 and up 1, over 2 and up 4. This negative is going to flip everything over. So instead of going over 1 and up 1, we go over 1 and down 1. We go over 2 and down 1, 2, 3, 4. Same in the other direction, over 1 and down 4. All right. The last type of function they're going to give us is potentially a square root function. Which looks like that. It's kind of like if you were to take just the top part of this parabola, if you turn it sideways, it looks basically just like that. So it starts again at 0, 0. This one goes over 1 and up 1, but instead of going over 2 and up 4, it goes over 4 and up 2. That is the basic square root function. And then again, based off of shifts, left, right, up, down, flipping, it's going to do the same kind of thing. If they add or subtract inside of the square root, again, that's going to move you left or right. And it's going to move backwards. So again, negatives are going to actually shift you right. Positives are actually going to shift you left. Outside of the function, we'll shift things up and down. They'll move like they are supposed to. And again, if they put a negative in front, that's going to flip everything over. Now, the one thing that gets really tricky with this is they don't always put this one at the end. They may put it at the beginning. I'll do one that looks like this first, and I'll do one that looks like something else. So let's say we did y equals the square root of x plus 1 plus 2. Okay. Again, this plus 1 inside is going to shift us to the left, that many. This +2 outside is going to shift us up that many. This is where we start. And then this particular graph goes over 1 and up 1, over 4, up 2. And it looks like that. Like I said, where they're going to try and get cute and or tricky with this is if they write it like that. Even if they put this 3 here, it's the same as putting the 2 here. If it's outside of the function like this and you're adding or subtracting, okay, this is your up or down shift. And this 3 is actually a positive 3. So this is going to shift us up 3 units. This -2 is going to shift us to the right 2 units. So that's my starting point. The minus, okay, in front of the square root is what's going to take us and flip this thing over. So instead of going kind of up and to the right like that, we're going to go down. So we're going to come down 1 and over 1. We're going to come down 2 over 4. Like that. So 3/6 is really kind of a standalone thing. It doesn't match any of the linear functions. There's no slopes. You don't always get an X or a Y intercept. The big thing is you need to understand these parent functions. And again, my math lab is going to give you examples of all 3. On your test, I'm going to focus primarily on this one. I want you to be able to graph a quadratic given what we call vertex form. That's where I want you to pay specific attention. But my math lab will have you graph all 3. All right, last but not least, I want to talk about the exam. So again, next week, there is no lesson. There will be no Zoom because you guys are going to be setting up an exam with your proctoring site. And then at some point, just sometime next week, or actually starting tomorrow, the proctoring sites should have it. If you just want to get it out of the way and knock it out of the park, go for it. But again, you need to set up a test with your proctored site, and then you will be testing. It should take you about an hour. But anyway, your exam covers everything that we've talked about so far. So it covers both chapter 2 and chapter 3 steps. There are 3 questions that are going to ask you to solve an absolute value equation. There are 6 inequality problems. Remember, with your inequality problems, that's less than, greater than, less than, equal to, greater than, equal to, you need to be able to solve and graph and do interval notation. Okay, you need to be able to do all of those things. Okay, and there are 6 problems. There are 2 regular inequalities. There are 2 compound inequalities. And there are 2 absolute value inequalities. But for all of these, you need to be able to solve, you need to be able to graph, and you need to be able to give interval notation. I want to be able to see all of these things. We covered that first couple of nights class. Okay, switching to chapter 3, there are 3 questions talking about domain, range, and whether or not something is a function. They'll give you 3 different representations. One's a graph, one's got the bubbles with the arrows, and then one's a collection of coordinates. But you should be able to give the domain, the range, and tell me whether or not it's a function. There are 3 problems where if I give you a graph of some f of x, you should be able to tell me the input or the output. For example, if I said for this particular function, Okay. What is the f of 2? Okay, remember I'm asking what is the output when my x is 2? If my x is 2, okay, I'm right on the x-axis. That means my y would be 0. Okay, that would be my output. Okay, if I said the f of x equals 2, I'm asking which x value do I get a y value of 2? It looks like we crossed the graph here. So at 2, now I guess it could happen here or here, but you would need to be able to give me all of those x's. So it looks like at -1, looks like at 0, and wherever the heck that would be. So 2 point something or other. Okay. But anyway, there are a couple that ask you about inputs and output. There are going to be 4 problems asking you to graph a linear function. They can give you that equation in a couple of different forms. They can give it to you as an f of x equals. They can give it to you as a standard form, slope intercept form. But anyway, you should be able to graph some function or some other question, like they may ask you for what is the slope or what is the x-intercept. Remember, that would be some coordinate and then 0, or they may ask for the y-intercept, which would be 0 and then some coordinate. But you should be able to answer. So if I give you an equation, you should be able to graph it or give me the slope or the x-intercept or the y-intercept. There are 2 questions asking you to compare lines. Are these parallel, perpendicular, or neither? And we just talked about today. There are 4 questions where you're going to be asked to write the equation. Again, what we just covered today. So if I give you 2 coordinates or slope and a coordinate or coordinate and some parallel line, whatever, you need to be able to write the equation. So you're going to need to know that point slope formula. And there are going to be 2 nonlinear graphs. And I would focus on quadratics, that parabola. As far as the testing goes, if you looked at the schedule, this is the only test that covers 2 chapters. So unfortunately, this test is kind of big. As far as content, I mean, easy, hard, I mean, that's all debatable. But this is kind of this will be the biggest test. It's the most questions by far, just because this is the only one that covers 2 chapters. Everything else, if you look, only covers like 1 chapter, probably 5 sections, maybe 6 sections. But the next few sections are much smaller. So this is kind of a big test. As far as grades go, the tests are big. Make sure you are prepared for this. You know about how many questions, the kind of stuff that's going to be asked. Go through, do practice problems. Make sure you're doing your homework. Make sure you're ready to go. I'm not trying to trick anybody. I'm not looking to get you. I want you to be ready. So if you have questions on stuff, email me. I do my best to get back to you relatively quickly. Again, there will be no Zoom lesson on Thursday, just next week at some point. Contact your site and you guys are going to be taking your test. That's all the new information I have. If you guys have some questions, feel free, ask them. I'll be here till 8:15. I'm here the whole time. So feel free to stick around. But if you're done, you feel comfortable, I'm not presenting anything new, you're good to go. And I'll see everybody in 2 weeks.